Hello, this is Miss Pellegrin. Today you were asked to solve these portions using the butterfly method. So we're going to go over that butterfly method today. It's just one of the options that we have when we're dealing with scale drawings or portions, things that are equivalent to each other. So I would always multiply times my variable first. So 7 times f is 7f. That way the variable ends up on the left side. That's just preference. We like to see the variable on the left side. 1 times 22 is 22. And then we have to get f by itself. One of our options is to multiply by the reciprocal. So the reciprocal of 7 is 1/7. Because then the 1s would cancel and the 7s would cancel, leaving me with f equals, and then and then you're multiplying straight across. So 22 times 1 is 22, and 1 times 7 is 7. So f is equal to 22 over 7. We're just going to leave them as improper fractions for today. R times 9 gives me 9r. 5 times 25 gives me 125. Divide both sides by 9. So r is equal to 125 over 9. Okay, so that was just the second option to get r by itself. You could multiply by the reciprocal or divide by the coefficient, the number in front of the variable, because 9 divided by 9 gave me 1r. Whichever is your preference. 7 times b gives me 7b, and 5 times 25 gives me 125. Multiply by the reciprocal. Choose your way. So that the 1s cancel, the 7 cancels, leaving me with b equals 125 over 1 times 1 is 125, and 1 times 7 is 7. Okay, so if you flip your paper over, you were given some similar figures, and you were asked to find the scale factor, and you're also asked to find x. Okay, we have a couple of different options for how we're going to do this. According to the author of your book, we can use our tables, and we can set up a table and use our equations. And so we'll do that for the first one. In our table, we've been setting it up like this. We've said the original times the scale factor. Scale factor gives you your new. And so this would be our original, and this would be our new. Okay, so the original, we need to look and see which sides are corresponding. So 9 is corresponding with x. So our original measure was 9, and that corresponded with the new side that had a measurement of x. And then the 4 in the original corresponded with the 2 in the new. Okay, so our scale factor is 4 times what gives me 2? I don't know, so we are doing the new divided by the original, which would be 2 divided by 4. 2 will go into 2 once, and 2 will go into 4 twice. So I'm multiplying times 1/2. So that is our scale factor. Our scale factor here is 1/2, which makes sense. You can see the picture is getting smaller, so it's a reduction. So it means that it is going to be less than 1. And then we needed to find x. So we are multiplying 9 times 1/2. And so 9 times 1/2 gives me 4.5. And it's centimeters. our equation would be y is equal to, oops, not 4.5, 1/2 x. So we were given the original, which is always our x. So y equals 1/2 times the original, which was 9. So y equals 9/2, which is 4.5. That's where I'm getting x is equal to 4.5 from. We're going to need that later at number 3 using the equation. So we're showing to use that equation. In the second one, we will use a proportion. So the 8 and the x are corresponding to each other. And then the 5 and the 7.5 are corresponding to each other. So the 8 goes with the x. The 5 goes with the 7.5. And they are equivalent. Okay. If you switched So if I set this up the other way, if I had the 5 on the top, then the 7.5 would need to go on top. The corresponding measures need to be horizontal from each other. Okay, so we're going to cross multiply. 5 times x is 5x equals 8 times 7.5. 8 times 7.5 gives me 60. Okay. Choose how you're solving for x. I like to divide both sides by 5, so x is equal to 12. However, we also want to know what is the scale factor here. Okay, and so then we have to go back to what we see on the left side, which is scale factor is the new divided by the original. So scale factor equals the new divided by the original. So the new was 7.5. The original was 5. So 7.5 divided by 5. 7.5 divided by 5. When I'm thinking about that, I'm thinking I should be getting a number that is greater than 1. And I do, I get 1.5. Because your image is getting bigger. So my scale factor here was 1.5. And so we can just test, make sure that that's correct. So that means 8 times 1.5. 8 times 1.5 should give me 12, and it does. Okay. Let's look at number 3. Okay, so in number 3 we have a reduction. Our scale factor should be a number that is less than 1. And so with that, I'm going to do the table. I'm using the table to help me to understand what I'm doing here, to set it up neatly. And so we have that this is going to be our original, what's at the top. Just like in a table, that would be my x, would be at the top. And at the bottom, our new would be our y, or in a table, that's how it would be set up as well. So our original and our new. So our original had 6 at the bottom, and it was corresponding to 4.5. 6 and the 4.5 corresponded. And then we had in the original x, and in the new it was 6. So these were corresponding. Okay, so scale factor is the new by the original, divided by the original. So 4.5 divided by 6. So 4.5 divided by 6 gives me a scale factor of 0.75. And so that means that I'm multiplying 6 times 0.75 to get 4. However, here I'm multiplying something times 0.75, so we need to go the other way. So that's why I said let's use an equation. Y equals 0.75x. In this case, our original is our x, and so what we're given is we're given y. Y was 6 equals 0.75x. Get x by itself, so we're dividing both sides by 0.75. So 6 divided by 0.75 gives me x is equal to 8. And I'm going to check and make sure, does that make sense? Yes. This side should be bigger. The original should be bigger than the measurement on the new because it was a reduction. So it does make sense. Okay. So on number 4, let's do that one as a proportion. We've done 2 tables. We'll do 2 proportions. Okay, so 6.4 and x are going together. So 6.4 and x are going together. And then 12 and 15. So 12, this all of the originals on the left side for me. And then 15. And that's a good way to set it up. Okay, and so we're going to cross multiply. 12 times x is 12x equals 15 times 6.4. 15 times 6.4 equals 96. And I can divide both sides by 12. So that the number in front of x is 1. And 96 divided by 12 is 8. Again, I still need to find that scale factor. So scale factor is equal to the new by the original. So the new is 15. The original is 12. And it is an enlargement. So 15 divided by 12 is going to give me a whole number. And it should. 15 divided by 12 is 1.25. So a number greater than 1 is my scale factor. Okay, you're going to pause the video, try 5 and 6 on your own for 5 minutes, and then play the video to check your answers. Okay, hopefully they didn't get you on these 2, and you were able to pair up the corresponding measures. If you notice, they were turned a little bit in 5 and on 6, and so you had to look at the dots for references in those triangles to see which sides would correspond. So our scale factor, if you were looking at the original being the one on the left side and then the one on the right side is your new, your scale factor was 1/4 because it was getting smaller. If you had actually looked at it from the small one was at the top and the big one is at the bottom, meaning it was an enlargement, and you said your scale factor was 4, that would have been acceptable as well. Either way, you would have gotten x was equal to 4. So I would have accepted if you were able to say y and explain that you thought that it was a top to bottom, not a left to right comparison. Okay, and then on number 6, the scale factor was 5 over 3.5. Those were the corresponding measures. So new divided by the old.